Okay, so this class is brought to you by Advanced Mathematical Research by Ibrahim sir. Advanced Mathematical Research by Ibrahim sir. Okay, today I am going to discuss a physics problem. Okay, the problem is a sphere of mass m rolls without slipping on an inclined plane of inclination theta. Okay, find the linear acceleration of the sphere and the force of friction acting on it. What should be the minimum coefficient of static friction to support pure rolling? Okay, I think that everyone got it. So you have to find the linear acceleration of the sphere and the force of friction acting on it, and you also have to find the minimum coefficient of static friction to support pure rolling. So let's see the solution. Draw free body diagram. First you have to draw the free body diagram. So FBD, you must have learned what is FBD, free body diagram. Okay, so we will consider an inclined plane. Let's assume that theta be the angle of inclination. Okay, now according to the question, we have been given a sphere of mass m. So this is a sphere of mass m. Okay, so if the sphere is having the mass m, then say what will be the force that is acting downward. This force will be its weight, and that must be equal to mg. Okay, that must be equal to mg. Now it is falling with the acceleration. This is the acceleration of center of mass. This is the acceleration of center of mass. So let's assume that this acceleration be a, and this is a normal contact force. Everyone knows that normal contact force is always perpendicular to the plane. So this is my normal contact force. Okay, and this normal contact force will always be perpendicular to the plane, and we can see that this line is parallel to so we can see that this line is perpendicular to the plane. Okay, now this is the normal contact force, and now this is the force of friction. We know that the force of friction always works so we know that force of friction works onto the contact, and it is always opposite. This force of friction will always be opposite to the acceleration. Okay, now why this force is acting this way, we have dealt with this in our class of friction. So since there is a pure rolling, if there will be pure rolling, then this type of friction will be what type of friction? This will be static friction. Okay, this will be static friction. Now this is the force of friction. Now forces acting on the sphere are weight mg, the normal contact force, force of friction, and let's assume that a be the acceleration by which the center of mass is moving. Okay, so again I am drawing the free body diagram. Okay, so let's assume that this be the angle theta. Now this will be mg times cos of theta, resolution of vector. Okay, and this will be mg times sine of theta. So I think a resolution of vector, you must have read about resolution of vector, or nahi kiya to I will cover that in my class. So decomposing mg into two forces, one is mg times cosine theta and other is mg times sine theta, and let's assume that a be the acceleration and this is the force of friction. Now applying Newton's second law along axis parallel to the inclined plane. So what the Newton's second law of motion says, sum of all the forces must be equal to mass times acceleration. So what are the forces that are acting along the inclined plane? So mg times sine of theta is considered as positive. Okay, because that is we are considering the direction of mg times sine theta to be positive. So mg times sine of theta, and the force of friction is in the negative direction, so that will be minus of f, and that must be equal to mass times the acceleration. What is the acceleration? Acceleration is the acceleration of center of mass. Okay, that is the equation 1. Now, as the sphere rolls without slipping, its angular acceleration about the center is given as alpha, and that must be equal to linear acceleration divided by radius. So equation of rotational motion about center of mass is, so total torque must be equal to what? Moment of inertia multiplied by angular acceleration. So total torque must be equal to moment of inertia multiplied by angular acceleration. So what is the total torque here? Now the torque will be produced only by the force of friction. Why the torque will be produced only by the force of friction? Because the force of friction is not crossing through the center of mass, and we know that force of friction is at a distance, perpendicular distance r from the center of mass. So what will be torque? Torque must be equal to r cross f. So r cross f. Now the angle between r and force of friction is 90 degree. So what will be r cross f? So r cross f will be equal to r times f times sine of 90, and sine of 90 is 1. So that will become f times r. So it will become f times r. Okay, it will become f times r, and that is equal to moment of inertia of this sphere. So what is the moment of inertia of this sphere? 2/5 times mr square. And what is the angular acceleration? Angular acceleration must be equal to linear acceleration divided by r. Okay, so solving this, we can find the force of friction as 2/5 times ma. Okay, now solving 1 and 2, equation 1 and 2, what we can say that the linear acceleration a must be equal to 5/7 times g times sine of theta. And what is the force of friction? 2/7 times m times acceleration. What is the acceleration? 5/7 times g of sine theta. So finally we are having force of friction as 2/7 times mg times sine of theta. Okay, so again the same procedure, I'm just reiterating it. Now applying the Newton's second law हम लोगों ने apply किया. We got the equation 1, then we got equation 2, and now solving these equation 1 and 2, we got acceleration as 5/7 times g sine theta, acceleration due to gravity times sine theta, and force of friction is equal to 2/7 times g sine theta. So the normal force is equal to mg times cosine theta. Why? As there is no acceleration perpendicular to the inclined plane. So what we can say? We can say the weight downward, that is mg times sine theta, will balance the normal contact force. So normal contact force will be equal to mg times sine theta. Okay, the maximum friction is equal to mu times normal contact force. The maximum friction will be equal to mu times normal contact force, and that will be equal to mu times mg cos theta, where mu is the coefficient of static friction. Now moving further, thus for pure rolling, we can say mg times cosine of theta must always be greater than 2/7 times mg sine theta. What is the meaning of this? Can you say what is the meaning of this? Here we can say that the maximum friction is equal to mu times mg times cosine theta. So here we can say that mu times mg times cosine of theta. Here will come the mu. Okay, so mu times mg times cosine of theta must always be greater than the force of friction. What is the force of friction here? 2/7 times mg times sine of theta. So mu times mg times cosine theta must be greater than 2/7 times mg sine theta. If you solve it, then you will see that mu is greater than 2/7 times tan of theta, because mg and mg will cancel out, and sine theta divided by cos theta will become tan theta. So this is a very important question for rolling motion. Okay, so like and subscribe to my channel, and you can also join my class that is in Patna and Jahanabad. Thank you very much.